In this video we will create this rounded PCB board, which diameter is this 50 millimeters. This board is designed for BLDC motors and it has these 3 Hall sensors and they are distributed 60 degrees from each other. Here I have placed these decoupling capacitors for these ICs and here we have 10 picofarad capacitors for this inputs and outputs. And here we can see this Hall 1, Hall 2 and Hall 3 connector. First we have to create new electronic design. And from here we can create new schematic. And now we can start placing components for this Hall board. So I'm using these Hall sensors. We can place 3 of them. And I will already rename this, so this is Hall 1. Like that. Then we can place this ground components. Double click here. And then we can place this decoupling capacitors. And I will set this 100 nanofarads. Then we can draw this VCC supply voltage and from here, and I will move this a little bit more there. Then we can place this supply voltage. That. And then we can draw from this output. Just double click here and create line like that. And from here we can use this name and we can name this Hall 1. Now I search for connector. It is this one, and from here this 90 degrees. So I will place it mirror tool. I will place it here. And now we have this named wires here, so we can also create here. Just double click and create this. And now we can connect this just by using the same names here. So this will be this VCC. And now this one and this, they have the same label name, so they are connected. And this will be this GND ground. And here is all these hulls we have defined here. So this will be hull 1. and half 3. And now I will add some capacitors for this connector. Place 3 of them. And this is 10 picofarads. And I will connect grounds here, and we can check that they are connected correctly. And then I will make lines here. And now we can connect to these by using these names. So the reason why I'm using these names, because I think it would be it's not so easy to read this schematic if I have to connect this here and then there, and there is a lot of things going on, so I think this is more clear to read. So now we have all this schematic here, and actually I will move this a little bit more here. Maybe this here, so now they are symmetric. Now we can save this, and I'll sensor. And then we can switch to this PCB document. So now we have this PCB document here. I will close that. And here we have this origin point, which is this 0.0 millimeters, which was here. So what I do, I will move this to 25 and this minus 25. And then this one 25. Then this one 25. And now I will take all these, they should be all this 25. Now this, there it's correct. Here it is correct. There, okay, so now they are all correct. And now we can make this rounded corners just from here, this meter tool. And I will click here, and then this is 25. And now I just click all these corners. And like that, we have now this board. And now we have this origin here, so it is a lot easier to make this symmetric because we have it here. So now I can draw this outline circle, and I can start it from this 0.0, and I know it will be centered. Then I can move this somewhere there. I think this was maybe 12. Then I can place, I have to use this mirror tool here because this is bottom side. I will place this somewhere close here. I will rotate this one. So this hull tree is upside and this ground is bottom side. That. And now by pressing Alt, I can use this line movements. So now I can connect this here. Like that. And then I will place, I will select these. And then from here we have this arrange, and I will use this. And again, this will be easier because we have this 0.0 here, so we use 0.0 here. And then this angle, and it was 120, and this radius is, it was 20 maybe. So now it have already placed them there, and I'm gonna move this start angle so it's not on that connector. Maybe 108 was correct. Not this. So here 180. Okay, so now it's there, and it even rotates this Hall sensors like that. So now we have them there. We can press done. Now I will place this decoupling capacitors here close to this VCC and ground pins. This one. And from here we see this is 60 degrees, so we can also rotate this 60 degrees. So then they are aligned like this. And now pressing Alt and move this closer here. So placing this decoupling capacitors, to say they should be as close to this pins as possible. And then we have this, so there is 120. We can even copy this there. I will move this a little bit here. And now we could make this polygon pores. So I will use ground for bottom side. And we can just draw like this. Now we have bottom plane is ground, and then we can create VCC for this top plane. And now what we have to do, we can connect these grounds by placing like this, and then click here and press middle mouse click button, and it will create this via. So now it's connecting to the ground plane, which is bottom side. Then we can create same thing here. I forgot to press this button, so okay. And then this one. So now they are connected. Then we'll move this closer here. Then we can connect this here. Right. Here the same thing, so it's connected ground. All this. And if we will want to move this or there, so we have to use this one. So this is more free movement, so then we can place that. And after placing this, I'm always pressing ESC key, remove it from this routing. Then same thing here. So now we have all that. And now what we have to do, we have to route this HAL 1, HAL 2, and HAL 3. So it doesn't really matter what this bend we use. We can make it with this free tool and just draw some lines. Like this. It might be easiest this way because this is rounded board. Maybe we can use here this. So you can change that as a settings. And now I try to do same thing here. So starting from there. Go from here. So this is not prettiest way to do this, but should be totally okay for both like this. Looks like hand drawn these lines, but okay now. And then the last one, like that. And even this looks ugly, it will work totally fine. We can move this here. I'm pressing Alt key to move them. And now we basically have this. What we can do here, let's save. So here we have this, and what I do now, I will remove this C1 and this text from here, and we can add text this one. So I will close this now. So let's remove this. And this hull one can be somewhere there. And how to, we can change this somewhere there. I will change this also 0 degrees. Is it there? Now we can add this text this side. I will remove this. And total board. And let's use this name stop. And then here we can place this first. Now use this inspector tool. So here we have this align. I will use this center. And as we have this 0 point, we can, now it's aligned with this 0. And then let's say this is 20. And here I will use this side. Maybe this is, let's say 18.5. So now we have that there. And then last we will add this text bottom side. So what we had to do, this is top side, so bottom is names bottom. And now we can write this bottom side, and it will automatically rotate text so it is correct at bottom plane. So this first is VCC, so we can see this, writing it like that. I will use 8, this 0.8. Oh, now I think it should be all there. We can remove this text. And you can modify all these lines how you like. I think it would be look best if it's all routed from this outside. Some constant diameter, but for me it's fine like this now. Then we can push this 3D model and let's see how it looks. So now we have everything there. So I decided to create again these traces with this constant diameter. It took some time to figure out how to create this, but there it is now, and I think it looks more professional this way. You can try to create this too. Let me know in comments if you figure out how to do this.